So lately I've been sort of checking out this really fun puzzle that I got from a book called The Paper Puzzle Book, of all names. And it has you take a 5 by 5 square, and what you have to do is try and fold it down into a series of challenges. So for example, how do you fold this 5 by 5 square into this 3 by 3 where just the center square is revealed? So what you would do is fold the right side as a valley fold, left side as a valley fold, top and bottom, and there you have it. Okay, so you end up with the center square revealed in a 3 by 3. And there's about 50 different puzzles that you can make from this 5 by 5 square. So I've been talking a lot to my students about how to make a 5 by 5 square. So what we did was we took a rectangular piece of paper, folded a square, folded that into an 8 by 8, and then just cut out the 5 by 5. But there's actually a way to fold a square paper into fifths, and it's kind of an interesting way of folding, and I wanted to figure out why it worked, figure out the algebra behind it. So to sort of help us, I'm going to pretend that this corner down here is the coordinate 0, 0, and this coordinate over here is 10, 0, making this coordinate 10, 10, and this one at 0, 10. So we'll sort of imagine that this square is 10 by 10. All right, don't be fooled by the units on my mat here. All right, so the first step to folding into fifths is to take the paper and fold it in half, but you actually don't fold it all the way. You just sort of bring the bottom and the top together and then just sort of make like a little crimp over here on the right-hand side. So now when I open it up, that point right there would have a coordinate of 10, 5, right? Because it's the midpoint between the top right corner and the bottom right corner. So then the next step of the folding into fifths is to basically fold a crease between that midpoint crimp and the bottom left-hand corner. Right, so we're basically going to attempt to fold this crease right here. And definitely a straight edge would help, but if you take your time and make sure you go through that point here, and let's see if I can get it. I hope I can get it. I hope I can, I hope I can, I hope I can. Off a little bit there. Let's see if we can get it better. All right, this is live TV, folks. So I'm just going to try and muscle this up a little bit more. All right, I think I got it. Okay, so there we go. So this crease right here, we're going to now think of that as having a linear equation associated with it. So again, this is the origin. It goes through the point 10, 5. So that means it has a rise of 5, a run of 10, passing through the origin. So this fold would have an equation of y equals 1/2 x, or 5 over 10x plus 0, right? Now, when you fold paper, imagine that fold as the perpendicular bisector between 2 points. So this fold is the perpendicular bisector between 10, 0 and where 10, 0 ends up after that fold. So I'm going to take my straight edge and sort of approximate. So okay, so that point's right about there when I sort of reflect, right? I'm reflecting 10, 0 over that fold to that location there. So I'm going to connect that reflected image with its pre-image. And that segment is bisected perpendicularly by this fold here, y equals 1/2 x, right? So let's find the coordinates of this midpoint, which I will call M. And then we can find the coordinates of this point, which I will call A. Now, I know that this line here has a negative reciprocal slope because it's perpendicular. So the negative reciprocal slope of 1/2 is -2. So I know that the slope is -2. I also know that it goes through 10, 0. So the equation for this line here is y, if I were to use point slope, it'd be y minus 0 equals -2 times x minus 10. And to clean this up, it'd be y equals -2x plus 10. Now this point M is the solution to a system of linear equations between this fold here and this fold here. So let's solve a system of linear equations. Y equals half x and y equals -2x plus 10. Oh, sorry, 20. Just caught that. That would have been tragic. Okay, so let's solve that system of equations right there. So let's bring these together. I'll have half x equals -2x plus 20. Let's move my 2x's over, so I'll get 2.5 x equals 20 and x equals 8. So if x equals 8, when I substitute that into this equation here, I get y equals 4. So this point right here is 8, 4. All right? Now, to find the coordinates of point A is the end point of the segment that has 8, 4 as a midpoint. So I'm going to use my midpoint formula. And do some substitution because this midpoint should be 8, 4. And it's the midpoint between 10, 0 and whatever A is. I'll call that x1 and y1. Okay, so here we go. So let's make some substitutions. So x1 plus 10 over 2 has to equal 8. Well, it means x1 plus 10 is 16, which means x1 is 6. And then y1 plus 0 over 2 has to equal 4, which means y1 plus 0 has to equal 8, which means y1 has to equal 8. So this point A is at 6, 8. Now, after you fold this here, the next step of the process for folding into fifths is to take the top and fold it down along this line here. So I'm going to actually flip my paper over and fold this so that I have a parallel fold through A, now parallel to the top of the square. All right, so something like that right there. Okay, so I've got my fold here through point A, which is at 6, 8. Now, this right here is 1/5 of the height of the square. Why? Well, because remember, this is 10. This fold here would be y equals 8, where the top would be y equals 10. That's 1/5, right? So now what they do is they have you now take the bottom of the square. I'm going to fold this over here. Take the bottom of the square and fold it to this point here. Now that fold that I just made is halfway between 8 and the bottom. So the bottom would be, of course, y equals 0. So this being halfway between 0 and 8 would be y equals 4. And now I'm just going to fold this in half. So halfway between 0 and 4 would be y equals 2. And then to get the last one, I'm going to now fold this y equals 8 line onto the y equals 4 line. All right, and then open that up, and there you have it. Y equals 6. So this is just really really cool. I love the way the algebra supports the paper fold here. So now this right here is 1/5. This is 1/5. And again, and again, and again. Now, if you need to make it 5 by 5, then all you do is turn your paper 90 degrees. I'm going to dog ear this corner right here to match this crease here at y=2. And then I can fold that over, right? Making sure that I've sort of used that miter fold or that dog ear fold as sort of a wedge and make sure that these folds line up nicely. And I do the same thing. I'm now going to bring this up. I just love how this works out, how the algebra supports the paper folding. Like, to me, that is just so cool, right? Love this. Absolutely love this. Get this all lined up nice. And then when we flip it over, you'll see a nice square divided into fifths. I just love how this works out. So I hope you enjoy it as much as I do. This is a fantastic way to teach students about systems of linear equations. You got midpoint formula in there, perpendicular bisector. It's just a magical way to teach a little sort of integration of algebra and geometry using some paper folding. So if you have any questions or suggestions, please feel free to reach out to me. And thanks so much for watching.